Is my screen visible?
Yes, Bhaiya.
Yes.
Yes, it is.
Okay. So in today's session, we'll be seeing the fundamentals of C language. We'll be learning what are variables, data types, literals, constants, declaration, initialization, then this program stack, what is the scope or lifetime of the variables, keywords, identifiers, then preprocessor directives, then global and local and static variables, how to take input from the user, how to display the output of the program using scanf and printf. So the first topic is variables. So now what do you mean by a variable means? It is a sort of memory location where you can store a particular value. Now, why do we actually need a variable is like when you're printing your hello world program, you will be typing it as a string and that string will be directly displayed. But if you want, you can store that string in a variable and simply display the value of that variable. So the benefits of this is, suppose you have a long paragraph in which a particular value is being used many times. Suppose you want to make a change in that value, then every time wherever that value is coming, you will have to change it in that paragraph. But suppose that value you store in a variable, and if you have to make any changes to that value, then you have to simply update the content of your variable and then it will be reflected in your paragraph. So again and again, you don't have to make the changes in the paragraph. Just update the variable and that will be reflected in the paragraph. So there are different types of variables. It can help you in memory handling also. So on this slide I've written a variable in simple terms is a storage place where some memory can be allocated to it. Basically, a variable can store some form of data. Different types of variable require different amounts of memory and they have specific set of operations. Now a data type means the type of data which the variable can store. Since there are different types of variables, there are different types of data types. Now, so how do you declare a variable and how do you initialize a variable? So before using a variable, you first need to declare it. In Python, you can directly use the variable like a equal to 5 and then you can print the value of a. But in C, C++, Java and all, you have to first declare the variable. Like suppose it is an integer variable, you have to write int a semicolon. You have to terminate your program code with a semicolon. So int a equal to 5 semicolon, you can write like this also, or you can write int a semicolon, next line a equal to 5. See here example, uh, difference between variable declaration and definition. As you can see here, first I've written int a. This is what declaration. Then what is initialization? A equal to 5. Now these two steps you can do in one line also, like int a equal to 5 semicolon. This is declaration and initialization together. So from this example, we know that how we have to declare a variable. First the type and then the variable name. So as you can see a variable declaration, first you have to give the type and then the variable name. Like how we have done here, int a and then a equal to 5. So what is the type? Integer is the type of a and a is the variable. So if you want to declare multiple variables on the same line, how you'll write? Int a comma b comma c. You can write like that. Means type, then variable name 1 comma variable name 2 and so on. So int a is declaration, a equal to 5 is the initialization. You cannot directly write a equal to 5. First int a, then a equal to 5 or int a equal to 5. Now these are the common data types in C language. First you have the primitive data types, then the derived data types and user defined data types. So in primitive, what all you have? You have Boolean, character, integer, floating point, double and void. Now we'll start with integer. Integer means any integer value you can store in this type of data, like say 5, 6, 102, and so on. You cannot include any decimal value if the type is integer. Now in floating point, you can give examples like 3.14 or 36.2. Such examples are for floating type, means decimal values you can include. And after the decimal point, there is certain number of digits that you can give. So this is called precision. What is precision? The number of digits after the decimal point is precision. So float has less precision compared to double. Double is another data type where you can store decimal values itself, but after the decimal point, you can have number of digits. The memory that double occupies is double of that of float. Suppose, so in memory, float occupies 4 bytes, whereas double occupies 8 bytes. Means it is the size which is double of float. So we'll understand now how much memory they occupy and all in memory later on. Now valueless or void, the sixth type. Void means empty, vacuum. It is nothing, means you have to not specify any value. So usually we use this in functions. Their return type can be void. So we'll see examples of void later on. Then you have boolean. Boolean data type can take only two values, either true or false. Now this concept has emerged from now Boolean data types. The concept has emerged from Boolean algebra. In ancient mathematics and ancient history, a mathematician or scientist named George Boole, he invented Boolean algebra. Boolean algebra can be used in digital electronics. Like suppose the voltage is given, then it is high or true or 1 means the LED will glow. Means voltage is given, that is represented by 1. And if voltage is not given, it is represented as 0 or off, that is false. So that is digital electronics, but in computers, true and false are the two Boolean values. True means it indicates presence of something, false is the absence of something. So true is 1, false is 0. Suppose you want to write Boolean in the form of integers, how you will write? For true, you have to write 1. For false, you have to write 0 if you want to represent Boolean value in integer type. So we have discussed Boolean, character. Now what is character? Character can be a simple single alphabet like A. You can have a number 1, 2, whatever. Any special character like dollar. And whatever is a single character that should be enclosed within single quotes. See, I'm writing at the right hand side. Suppose A is a character. You have to enclose it within single quotes. Means how you will write int variable name equal to within single quotation A. For example, int variable name is equal to within single quotes A. Okay, we'll see this in our programming example. Now, I had informed you all to install the dev C++ IDE, or you can use an online compiler or the mobile app. So have you all installed it? Anyone? Either online compiler, you can use.
Yes, Dev C++.
Yes.
Yes.
Yeah.
Yes.
Okay,
Yes.
okay. So we'll start with the practicals now. So first what you have to do, okay, before that I'll show you what is online compiler. Now just open a new tab in your, means I'm just showing you how to do it. In your search bar, type online GDB. GDB is a type of compiler. There are different types of compiler like G++, GCC. This is a GDB compiler and click enter. The first link that you get, online GDB, click on that. So this is the online compiler. Now this compiler supports compilation for different types of languages. How do we know which language we have to use? See here at the right. here there are different languages: C, C++, C++14, C++17, Java, Python 3, HTML, CSS, R, Objective-C, and many other types. So now we are using C language. So select C. Now you can see there is already some code written over here. So what we will do is, for now I'm keeping it like that only because these are what we need. Hash include stdio.h, int main. This is your hello world program, printf hello world. So now this is already given to us, but we will type it from scratch. So I'm opening my dev C++. Now you can go to file, new, and source file. Or what is the shortcut, keyboard shortcut? Control plus N. When I click Control plus N, see I'm getting a new blank unnamed file. So first, what is a statement? This is the in the last lecture, we have studied the different sections of a C program. First comes the documentation part. It is not a part of the program. Next, what comes? The linking section. That is your hash include stdio.h, hash include conio.h, that part. After that, what comes? Your global declaration or your constant definition. Okay, so first we'll write the hash include part. Hash include stdio.h. Dot h indicates that it is a header file. Means this file is a link to the C library. The C library code was written previously by the C language developers. So we can directly use that code. We have to not write anything. We have to just call the functions written in that code. So hash include stdio.h. For now, we are using only this header file. What will be a second statement? It will be a constants if you want. For example, hash define. This is the syntax, okay? Hash define whatever your variable name is and what constant value you want to give, 23 suppose. Now you might have studied identifiers in your programming and problem solving. So there's one rule for identifiers. It is not compulsory, but if you have constants, if you have your constants, what you have to do, it should be in capital letters, okay? It is the community guidelines, means people expect that you declare the constants using capital letters or uppercase. This is the constant. So whenever in your program you write capital VAR, it will represent the value 23. But for now we don't need any constants, right? So I'll remove this line. So after your constant, your global values. But this program, I'm not using any global values, so leave it. Next, what will come? Your main function. So there are two ways, or actually more ways, but there are basically two ways to write your main function. Execution of your program will start from main. So what you have to do? Either you do void main, give your opening and closing round brackets. Next line, open curly bracket, close curly bracket. Now I just opened the curly bracket, but this ID completed the closing bracket for me. So I have less work to do. I have to just open, automatically it will be closed. So suppose in case in between you forget to close any bracket, that chance is very less because it is already automatically completing the closing bracket. Now this is a function. So functions can return some value, but here I'm not returning any value. So what will be the return type? Void. It is not returning any value. There's absolutely nothing to return. So it is valueless or void. It is written as void over here. So I'm just writing the syntax of a function here. How we have to write the function? Return type. Then after your return type, the name of your function, then your brackets or parentheses it is called, and then whatever arguments or parameters you want to pass. Then you have to open and close whatever your statements are. Give a semicolon. If there you have to return any value, return that value. Suppose you want to return 12 or 12 is stored in some variable, then you will write the name of that variable, semicolon. Okay, this is the basic syntax for any function. Its return type, then the name of the function. If you want to give any arguments, opening bracket, closing bracket, some statements, terminate it with a semicolon, If you want to return any value, write that value or the variable which stores that value and semicolon. So we'll see one example of a function now. As I said, first return type, suppose integer. Name of the function, suppose sum of numbers is the function. Opening and closing bracket. Give argument, suppose. When you're giving arguments, int, argument name, suppose. Whatever your statements are. Okay, this is just an example. Now, if you want to comments, you have learned about comments in Python. How do you give single line comment in Python? Hashtag, right? Let this you write it, hash and whatever your statements are. And if you want to give multi-line comment in Python, what you do? Triple quotation or like this. And then whatever statements are on the next line, you can again write your statements, whatever, and then again triple quotation. But this was in the case of Python. Now in C, how you give comments, I will show you. So if you want to give single line comment, you have to give 2 times forward slash like this. Okay, this is single line comment. After this, you can write whatever this, like this program is for demonstration. Okay, this is a single line comment. So means whatever you write after this double forward slash, that will not be executed in the program. It is just to give some description about what your program is doing. If you want to give multi-line comment, how will you do it? You have to give 1 time forward slash once, then your asterisk or star, whatever you call it. Then you can write your comment, whatever you want to write. You can write it a number of lines, and then you can write how to close the multi-line comment, asterisk and forward slash. Okay, so forward slash star, write your comment, and then star forward slash. This is a multi-line comment. So these statements will not be executed. They'll be ignored by the compiler. You will not get any error. Is this clear?
Yes.
Yes.
Okay. Now I'm showing you demonstration how to declare a variable. So void main, it does not return any value. So return type is what? Void. So now we are declaring a variable. Suppose it is of integer data type, int, variable name, suppose a, semicolon. This is what? Variable declaration. Now I want to initialize this variable. How I'll do it? A equal to, suppose 5 and semicolon. What is this? This is variable initialization. Now, one more thing. Suppose I've written here a equal to 5. I have not left any space in between all this. There is no problem even if you give space. You can also write a space equal to space 3 space semicolon. This is also okay. But you can write it like this also if you want. This is improves how well you can read it, readability, but this is also absolutely fine. So this was variable declaration. This is variable initialization. Now I'll show you how to do both in a single line of code. Suppose it is a, again, integer. Suppose variable name is b equal to 4. Okay. So within one line, I have first declared it. What I've highlighted, that is declaration. And then this part is initialization. So this whole thing is your complete declaration and initialization. Now, suppose I want to print the value of a and b. So which function I have to use? I've told you printf. Okay. So printf. Within your brackets, you have to mention double quotes. Open and close your double quote. And what you have to write, suppose I'm writing, you can write any string like value of a equal to. Now, what should happen? I should get the value of a over here. For that, what is the proper syntax is? You have to write percentage d. D stands for what? Integer. Percentage d means this is a called as a placeholder. Means instead of %d, your actual value of A will come. But it doesn't know that what value I have to put here. For that, what we have to do, after your closing quotation mark, comma, and then you have to write A. So first, how will it execute? What will get printed? Value of A equal to, and instead of %d, what will come? 5, because that is the value of A. Means what? This A that I've written here, that value will come instead of %d, and it will display. And terminate this line of code by a semicolon. If you don't give semicolon, you will get an error. So now let us, I'll comment this part also, otherwise it will give an error. So this is our first documentation part is over. This is your linking section. Constants we have not defined. There are no global variables. Then your main function, declaration, initialization of variable A, declaration and initialization together of variable B, printing the value of A at the console output. And if this is open, this should be closed. Now let's run it. How you have to run it is, I'll just check if someone is waiting to join. Okay, there's no one. Okay, we'll run this. How you have to run is, either go to execute over here. You can see my mouse pointer and click on first compile and then click on run, or compile and run is the third option. Together you can do it. Okay, so first we'll compile. So when it compiles, I've not saved the file, so it is telling me to save the file. So here at the bottom at my mouse pointer, you can see file name. I will save it as integer, sorry, my caps lock was on, integer demo. And here you can see this save as type. So it is currently showing C++ source file. Source file means the file in which you have written your program code. But I don't, this is not a C++ file. So what I'll do, I'll click on this. There are certain options, C, header file, resource script. So what you have to select? C source files. So you can see this .c as the extension. And then what you have to do? Save. So I've compiled it. I've not run it. Now this warning that you can see here, that is because I've changed the settings for C++ for this IDE, because before I used to deal with C++ programs on this IDE, but now I'm using it for C, so it is giving me this error. You will not get this error if you're using it for C for the first time. Okay, no problem if you get this warning. It will still execute. So now I've just compiled. Now I have to run. How will I do it? Execute and click on run. So see, it has run now. What is being shown on this thing? Value of A equal to 5. So see here, what has got printed? Value of A equal to value of A has been printed, 5. What we have initialized A to? 5. That has 5 has come here. Why 5? Because here A I have written after this. So value of A equal to 5. Now what you can do is, we'll print value of B. So what we'll write? Print F within double quotation, value of B equal to, what I'll write? Percentage D. After your quotation, comma, B and semicolon. Now you can also write like this. Suppose you don't want to write any message like value of B equal to. Then what you can do is printf within double quotation, you can just write percentage D and then comma, you have to write B. So what will happen? Only 4 will get displayed if I execute this line. No message will come, value of B is equal to whatever. So for now, I'll just comment this line. So what is the expected output? Value of A equal to 5, value of B equal to 4. Now, before I execute this next program, what I'll do is, here I can see my console is open. Better is you close that window, because if many output screens are open, it may give you an error. So close your previous consoles or your output screens and then run it. So last time, how we run it? Execute, compile. After that, execute, run, or what you can do is execute, compile and run. So I'll do now execute, compile and run. So together it got compiled and it ran also. So here we can see a desired output, but it is not that readable. Why? I'll tell you. See, value of A is equal to 5. Okay. Value of B is equal to 4. Correct. But it would be better if I can display value of B, that line, on the next line at the output. So how we can do that? Either you give here or here. Here I prefer to give, what you have to write? \n. \n is an escape sequence. Means what it will do? First, what will happen? Value of a equal to 5 will get printed, and then value of b equal to 4. This line will come on the next line when you give \n. It can introduce a new line in your output. It is a new line character. Okay, now we'll close the previous output screen and we'll run it. Now this, okay, first what I did, compile, then I did run. Then second program, what I did, compile and run. Another way is you can click on this button. See, I'm showing you here this button. This button is for compile. This is for run. This is for compile and run. So simply I'll click on this button. So it will get compiled and run at the same time. So see here, value of a is equal to 5 and value of b is equal to 4. Now suppose, as you can see here, there's one small space over here, this space. Okay, so what I'll do, I'll remove this space from here. Now let's see whether that space goes or no. Yes, it has gone. So as you can see, value of a is equal to 5 is first line, value of b equal to 4 is the second line. I'll close this.
Hello,
So
Bhaiya.
this was, yes.
What is the need of percentage %d?
See, percentage d, what it does is, it will act as a reserved space. This, wherever you write %d, there what will come at the output, the value of this variable will come in place of %d. So in the string you have to write value of a is equal to %d. What will come in the output? Value of a equal to, instead of %d, the value of a will come. Why I'm saying value of a? Because I've written comma and then the variable name a. So a ka value will come over here in place of %d. D stands for decimal or integer. Means if a is an integer variable, you have to use %d. Okay, we'll see this. There are different like %c, %s. %s is for string, %c is for character, %f is for float. So we'll see all that. For now, we are dealing with integers, so %d you have to write. Is your doubt cleared?
Instead of %d, if we write only a, it will execute or it will show error.
No, no, it will show an error because the only this will come then. If I don't write %d, but still if I give comma a, it will give me an error. Okay, in Python it is allowed, but here it is not allowed.
Yes, and in C++ it's also allowed.
Yes, there we are using cout cin, no? Here we are using printf. So in C++ is little different, but in C, if you give comma a, that is valid in Python, but in C language, you have to give %d. If you are not
Okay.
giving a, also you'll get an error because %d means what you have to write there. It will not understand if you don't give a. Comma a if you give, then you'll get no error. Is it okay?
Yes, understood. Thank you.
Okay, okay. Yes. So we have seen integers now, how to print, and we have seen some basic string for this is called a string formatting, %d. Okay, so we have seen integers. Now I'll demonstrate floating values. For now, so that we can only see float at the output, I'll just comment all of this. Okay, so all this will get ignored by the compiler. It will not execute. So within your void main, I'm writing float float and whichever variable name. Okay. So before I demonstrate, I want to show you some examples. We'll first understand in better details. See, I'm reading what I've written on this slide. Each variable in C has an associated data type. 1 second. Each variable in C has an associated data type. Each data type means the type of the value requires different amount of memory to be stored. So let us briefly describe them. We'll see how much it occupies in memory and all. First is character. It stores a single character and requires a single byte of memory. Means whenever you write char a equal to some value, that value will occupy 1 byte in the memory. Now, I'll just tell you what is bit, byte, and all that. See here, I've opened Notepad. I'm writing something here. Suppose I write, now 1 bit is equal to, it can be either 0 or 1. This is not Boolean that I'm saying. 1 bit means that bit value can be either 0 or it can be 1. We say no binary number system means what? Binary means it can have only two values, either 0 or 1. 1 bit can be either 0 can be its value, or 1 bit can have value 1. Next I'm writing, this is called as bit. When I say no machine level language, everything is converted into zeros and ones. Each 0 is a bit, each 1 is a bit. So 1 bit is 0 or 1. Then what is 1 byte? 1 byte is, do you know what is the answer? What is 1 byte?
8 bits.
Yes, correct, 8 bits. Then what is uh, 2 bytes?
16.
Yes, 16 bits. Yes, correct. So similarly, you can have 8 bytes also. Now 8, okay, so you have 1 bit, 2 bit, 3 bit, like that. Suppose you have 8 bits together, it is equal to 1 byte. So 8 times 0 or 8 times 1 or 0101, like that combination, if you have 8 digits or 8 bits, it forms 1 byte. Now, suppose you have 16 bits. 16 bits is what? 2 bytes, correct? Okay,
Yes. Yes.
yes, 2 bytes. But you can also write it as one word. 16 bits is nothing but 2 bytes, because 1 byte is 8 bits, 2 bytes are each of 8 bits, so total 16 bits, and 2 bytes or 16 bits can also be called as one word. So if I write 32 bits, it is equal to 4 bytes, and 4 bytes is equal to, either you can say 2 word or you can say double word. And one more thing, 4 bits is equal to, you can say half byte, sorry, half byte, because 1 byte is 8 bits. So half byte is 4 bits, or you can say it as one nibble. Okay, so one nibble is 4 bits. So what is 8 bits? 2 nibbles. So 1 bit is 0 or 1. 8 bits will form 1 byte. 1 byte can be of 8 bits. 2 bytes are of 16 bits. 4 bits is one nibble. Okay, 16 bits is nothing but 2 bytes is one word. Okay, for now you just remember 1 bit is 0, 1. 1 byte is of 8 bits and 8 bits is of 1 byte. So I'll just remove all this. 8 bits is 1 byte, 2 bytes, 16 bits. 1 byte is 8 bits. Okay, so in between, if you want, you can take notes or screenshots of my screen. Okay, up to you how you want to take down notes. So I'll again go to the presentation mode. Now, char, we have seen it is a single character, like open your single quotation A, close your single quotation. This is an example of char. Integer, integer variable. Float, it can store decimal values with single precision. Double has double precision. Double can also store decimal values. Precision is number of digits after the decimal point. Now, as per your compiler or your operating system may be 32-bit, your operating system may be 64-bit. Now, inside the computer, you have software and hardware. Hardware is whatever motherboard, your disks, whatever. So these are physical components. You can see them, how they look and all. But software is just a program. So in your physical device, you can how to form your computer in terms of hardware. You have to use certain processors or certain microprocessors. So that processor can be of 8-bit, 16-bit, 32-bit, 64-bit, 128-bit. That is powers of 2 bits. Means what your operating system can do, if your operating system is 32-bit, it can represent data of 32 bits. If your operating system is of 16 bits, it can represent data in terms of 16 bits. So if your operating system is 32-bit, you have to install 32-bit Windows in it. And if you have 32-bit Windows and 32-bit operating system, you have to use 32-bit other applications like 32-bit ka dev C++ you have to install. So that's why I'm telling 32-bit system if you have, then your integer will occupy 2 bytes in memory. If your operating system is 64 bits, then your integer will occupy 4 bits in memory, 4 bytes, sorry. Similarly, float and double. Now we'll see what memory size they occupy. See here in this table, first type, character, it will occupy 1 byte in your computer memory. Unsigned char means what? The character will not have a negative sign. It will not have minus sign. See, suppose I say 24, it is a positive number. I say minus 24, it is a negative number. Negative numbers are signed numbers. You have a minus sign before the number if it is a negative number. We don't write plus 24. It is understood. It is positive 24. If we write minus 24, it is a negative number or signed number. So that is, here I'm writing unsigned char means what? It is there's no negative sign. It will also occupy 1 byte in memory. We'll see the last column afterwards, what is value range. Now signed char, it will also occupy 1 byte. Now integer, it will occupy 2 or 4. Why 2? If your operating system is 32 bits, if your operating system is 64-bit ka, then it will be 4 bytes. Unsigned means positive value of integer. Again, same 2 or 4. Short means a lesser range will be available for your integer values. Some small integer values you can store compared to what you can store in only integer. If it is short integer, less uh, value you can store, small integers. If it is integer, little greater value you can store. Unsigned short means positive short value. It occupies 2 bytes. Long, if you have, it occupies 8 bytes when 64-bit processor or 64-bit operating system. And 8 bytes if it is 64-bit OS, 4 bytes if it is 32-bit OS. Then unsigned long. Long means you're extending the range or extending the space that the value will occupy in memory. And you're also extending how many digits the integer can be. It is unsigned means positive, 8 bytes in memory. Float will occupy 4 bytes. Double will occupy 8 bytes. And long double will occupy 10 bytes. Now see the third column, value range means what? First is char. First is char. Now character can hold a value between minus 128 to 127 or 0 to 255. Means what? See a character, suppose it is A, the character A. A has certain ASCII value. Means what? This character A is stored in memory using a particular integer value. So here I'll show you. See at this slide. Here all your characters are written. All these are your characters. All these are your characters. All these are your characters. For this character A, the corresponding decimal value that it holds in memory, 65, means what? In memory, the character A is referred to as 65. In memory, the character B is referred to as the decimal number 66. These are integer values. All these are integer values. So like that A, B, C, D up to Z. So Z will occupy how much? Sorry, Z will have the corresponding number as 90. Z has 90. Then you have certain other characters like opening square bracket, backslash and all that. Then after some characters, you have small, lowercase a, lowercase b, 97, 98, 99, and so on, up to z. 122 is the number for z. Okay, now let's go back. So we saw character. So minus 128 to 127, whichever character's decimal value falls in this range, that will be, you will be able to store in a variable whose type is character. I repeat, if the ASCII value of a character is between 128 to 127, you can store that character in a variable whose type is character. Now integer. Now if you have 32-bit compiler or 32-bit operating system, you can store from minus 32 768 to 32 767. If you have 64-bit or large values or advanced compilers, see such a large number you can store. So many digits are there. Okay. Now, unsigned int means what? You will start from 0 and end at this value. Start from 0 or end at this value for large numbers. So only when I was saying, see here again, char, if it is signed means you have negative, then this is the range. If it is unsigned, this is the range. See, signed char is minus 128 to 127. Unsigned char is 0 to 255. Now, then you'll keep going like this on the number line. You'll get 0, and after 0, you'll go up to 127. So if it is a signed number, if it is not signed, what happens? This minus 128 to 0, this range is there, no, that will not come because all these are negative values. So from where you'll start? You'll start from 0, and 127 is for your regular character, but this is positive. So whatever this range is, then no, minus 128 to 0, this will come into the positive side. So you can again go to plus 127. So total how it becomes 255. So minus 128, minus 127, minus 126, you go on like that till 0. Then 1, 2, 3, 4, you go on up to 127. This total size is 255. If you count the number of numbers, it is 255. This is for your regular. If it is positive character, then what will happen? You will go from 0 to 255. If you count from 0 to 255, there are 256 numbers. And if you count from minus 128 to 127, there are 256 numbers. Okay. It's not that important, but I'm just explaining it to you. So just remember, integer will occupy 2 or 4 bytes. Your float will occupy 4 bytes. Double will occupy 8 bytes. And long double will occupy 10 bytes. I repeat. 1 minute. Okay. So I repeat, character 1 byte, integer 2 or 4 bytes, float 4 bytes, double 8 bytes, long double 10 bytes. Is this clear?
Yes.
Yes, yes. Yes.
Yes.
Okay. Yes. Now we'll see some written examples. An integer is a numeric literal without any fractional or exponential part. Means if you write 2 into 10 raised to 30, this into 10 raised to 30 is not valid in integers. You can just write 2, 6, 12, you can write 345, whatever your number is. And now there in integers also you have certain types, such as decimal, octal, hexadecimal. If it is a decimal number, what are the examples? Minus 9, minus 12, 0, 13. Okay, such examples you have. If it is an octal, you have studied number system in electronics, have you?
No.
You have not studied?
No.
Okay. So there are some, means in normal maths, how we write 0, 1, 2, 3, 4, okay. Like that in electronics, what happens is there are different types of systems of numbers. So what we write now, 0, 3, 4, whatever number, that is decimal number system. There's one more system, binary number system. Binary we have been using in machine language, zeros and ones. Bi means two values, 0 or 1. After binary, you have something known as octal. In octal, which numbers come from 0 to 7? In hexadecimal, which numbers will come from 0 to 15? There are certain number systems like that. Okay. So since you have not studied that, I won't explain this part. Consider decimal. You have certain octal and hexadecimal also. Later on, we'll study what is octal and hexadecimal only. We now come to floating. Now floating points, as I'm already mentioned, you can store the decimal numbers like 31.78, 1.34. Also, you can have numbers like 1.2 into 10 raised to minus 32. Such exponential values also you can have. And how many bytes it stores in memory? In the previous slide we have seen. Can anyone answer?
4 byte.
Yes, correct. 4 bytes. How much integer will occupy? 2 or 4?
2 or 4.
It, yes, it depends on your operating system. This is for 32-bit operating system. This is for 64-bit operating system. So we saw integer float. Now we'll see character. A character literal is created by enclosing a single character within quotation marks. See your example. Within quotations, you have A. Within quotations, F. Now a character, see, suppose I'm writing See, I'm writing 1 here. Okay, I'll write 2 here. This is an integer. Okay, this is an integer. But suppose I write 2 within your quotation marks. This whole thing will become a character. It is not an integer. So anything, it can be, suppose I'm writing dollar symbol, I have to enclose it within single quotation. Suppose I'm writing 253. This is an integer value. But suppose I put my quotation marks like this, then it becomes a character. It is not an integer. So suppose you write within quotations 253, you're storing it in an integer variable, then you'll get an error. Actually, you won't get error, you'll get its ASCII value. So we'll see that in our demonstration. That time it will be clear to you. So you've seen integer float character. Now integer input or output. See, this is a sample program. This is the data type integer. Test integer is the variable name, semicolon. Now printf, enter an integer, means what we are telling, where on the output what will come, enter an integer, this statement will come. Then you'll write scan. Okay, so see now I'm explaining scanf also. Scanf is used to take input from the user. Okay, so when you write scanf, it is a function. So these brackets you have to give. And within that brackets, what you have to do, first of all, you have to not write anything, only within quotation, what you have to do, %d. We want the user to enter an integer value. So I'm writing here %d. Now, after that, outside quotation, after your comma, what you have to write? This is called as ampersand. Okay, this symbol is called ampersand. After ampersand, what you have to write? The variable ka name. So what will happen? First, you have declared this variable, no? Test integer, this variable you have declared. This is variable declaration. Then here, through the user, when the user will enter a value, that we have to assign to this variable. So what will happen? Enter an integer, this message will come. Then user will type suppose 4. Then what will happen? That 4 which the user has entered, that will get stored in test integer. So what happens internally, I'll tell you. When the user will type 4, that 4 will get stored at the address at which this variable is you have declared. So what happens whenever you declare a variable? 1 minute. So here I'm showing you a notepad. Int a, suppose I write. What will happen? In memory, a space is allocated for the variable a. And at this space, you can store the value of a. So when I write int a, some memory will be created. Just a minute. Okay, see here, I'm using two screens at a time. In your notepad, I've written int a. So what will happen? A memory space will get created. And how that memory space will get created, actually I'm not able to show here properly. Okay, I'll open Paint. See here, I've written int a. So what will happen soon as this line is executed? A particular memory space will be allocated in the computer, and that space will be named a. Okay. So this is a memory space, and what is the name of that? Which variable? A. And whenever now I write a equal to 5 semicolon. So what will happen? The value 5 will get stored within that memory space. Okay. Then what will happen? Suppose I write float b, and then I write b equal to 3.14. Then what will happen?
I think Shubham Patil wants to say something.
Yes, Shubham, what you want to say?
He has raised his hand, right?
Okay. So see here. Now I've written float b, and then I've written b equal to 3.14. So what will happen? In your computer memory, there will be one space of what size? See, float occupies 4 bytes in memory. So the size of this memory space is how much? 4 bytes. This memory space, this square that I've drawn, has 4 bytes space available in it. In this 4 byte space, what will happen? First of all, this will space is for the variable b, and within this space, which value will be stored? 3.14. Okay, you understood. When I write float b, a memory space is created of 4 bytes, and in that space, what will get stored? 3.14. And whenever I say printf and I want to print the value of b, what value will get printed? 3.14. From where that 3.14 is coming? From the memory. Okay. So now, how to use scanf? Scanf within brackets. First, you have to write %d within double quotes. Always use double quote for string. Don't use single quote. In Python, if you use single quote for string, it is okay. But in C, C++, Java, double quote for string. Comma, ampersand, variable name, and close your bracket. So before this, I have to tell the user to enter some value. So printf, and then I'll say enter value, close your double quotation, close your bracket, semicolon. Then scanf %d, comma, ampersand variable name. Now here this will give an error. I'll tell you why. Because we are writing here ampersand variable name. This is a variable. Suppose instead of this I write a. A is a variable, but I'm not declared it, right? I have to write int a. If I don't write int a and directly write scanf, it will give error. So int a is the declaration, and this scanf statement, it is doing the initialization for us. How it is doing initialization? The user will enter the value 4. That 4 will get assigned to a. So this is initialization, right? Int a equal to 4. Instead of doing int a equal to 4, I'm doing int a, user will enter 4 and that I'm assigning. Understood, right?
Yes.
Okay.
Yes.
So now in dev C++, I'll run this. So here I'm doing float b, semicolon. B equal to 3.14. First line is what? Declaration. This is initialization. I'm doing initialization by the user. So I won't write this line. What I'll write? Scanf, open and close, within double quote, %d, comma, what I'll write? Ampersand b and semicolon. Okay, before this, what I'll do? I'll write printf and I'll display a message, enter value. And then I want to print the value of b after user has entered it. So what will happen? Value of b is what? What I have to write here? Can anyone tell me?
%d.
Yes, correct. Very good. %d, comma. Now what I have to write?
B.
Yes, correct. Very good. So now what will happen? Float b, I've declared it. Printf, enter value. This the user can see. What the user will see? Enter value. So he'll understand how to enter some value. He will enter the value. That will get assigned to b. And now I'm printing that value of b. Okay, so now let's just run this program. So only this part I've kept, rest everything I've commented. So I'm compiling and running at the same time. See here, what is the very first thing that the user sees? Enter value. That is this printf statement. First printf statement, enter value. So what user will do? He'll enter the value, suppose 4.23. Then he'll click enter. After clicking enter, internally what will happen? 4.23 will get stored to Scanf. Now see here, there's a very important thing that you have to note. When the value of b is getting printed, it is coming 0. Now why it is coming 0? Because I've given %d here, which is used for integers, but my variable is of float type. So it is giving any garbage value, anything it will give. This time it has given 0, next time it will give something else. So instead of d, what I have to do? %f. Correct? Because it's a floating value, floating point value. Now when I run this program, what will happen? Enter the value. So I'm clicking 5.23. I click enter. Now this value of b is becoming, it's not printing the actual. Now here we have got one more error. Can you tell why?
%d.
%d is
%d.
written.
Yes, correct. Here
Yeah,
also I have to change it to %f. Because in scanf and printf, what is common? Your percent whatever, that is common. What is difference between scanf and printf? Ampersand variable name will come in scanf, but in printf only variable name will come. Okay. Now this is again an error we have got. Again we'll run the program and see. So let's check first if everything is correct. Floating, related to float I've used %f, related to float I've used %f. Here I've used ampersand, here I've not used. So everything is correct. Now let's see whether it runs properly. Enter value. So user should enter some value. I'm entering 2.34 or 2.45. I click enter. See, now we are getting the correct thing. Second print set, value of b equal to 2.450000. Why are you getting 0000? Because float after the decimal point, you will get 6 digits. See, 450000, 6 digits after decimal. This much precision you get. Okay. Now one more thing, and then it will be the last topic for the lecture. Suppose I run the same program again. Enter value. I write 2. I'm writing integer value now, 2. I click enter. See the answer, 2.0000. Means if your variable is float type and if you give integer value will get converted to float type automatically. This is called type conversion, which happens automatically by the compiler. Compiler itself will do. But suppose my variable is of integer data type and I'm entering a floating point value, you saw how many errors we got, right? So if the data type is larger, float will store 4 bytes. It is larger than integer, larger or equal to in some cases. So float is greater. So you can enter a lesser integer value. Integer occupies 2 bytes, float occupies 4 bytes. Integer values are smaller. You can store them in float type of variable. But if your variable is of type integer and you're storing a large value like float value in it, you'll get errors. Okay. So for today, actually, I had prepared a lot more. I wanted to, as I had mentioned, see here in whatever we had to cover today. So till now, we have just covered variables and data types and literals and declaration initialization. And we have seen scanf and printf briefly. So many topics are remaining that we will see in the next lecture. Or do you want me to continue? It's your choice. Should I continue or should we stop? Anyone can answer. I won't mind. Should we continue or should we stop?
Your wish.
You can continue.
Yeah, you can continue. You can quit.
No.
If we
Okay,
have
just
time, we can do it.
okay. So I'll continue just one small topic, one more I'll take, and then we'll stop. So we saw this just now, integer. Okay, we'll just do the hello world program and we'll stop. So from the beginning, I'll write everything. I'll show you, suppose, see now, I've closed my dev C++. How will I open it? I'm showing you. I'm clicking either on the taskbar or on your desktop. You can see I'm clicking dev C++. Here some message comes, just ignore it, click yes. Now go to file, click on new and click on source file, or what you have to do, control plus N. Now you have to type hash include stdio.h. Next, what you'll do, void main. Now what you'll do, print f within brackets and quotation, hello world, semicolon. Okay, it's only this much. This is your simple hello world program in C language. Now I have clicked on run and compile and run, but I've not saved my file. So first save it as a C type. And what name you'll give? Hello world. You have to not write hello world dot C, nothing like that. Just hello world. And you can have space between the name of your file. Hello space world is fine. Click on save. It will compile and run. As you can see, hello world has got printed. Suppose I write hello programmers. What will happen? Hello programmers is typed at the output. Now you can have other things also like get ch, return from main, but those things I will not explain today. Next time we will see. And today we won't have the quiz because our topic is not completely finished. In the next session, that will be on Saturday most probably, timings will be informed. That time we will do the remaining parts and we'll have the quiz. So everyone quickly put your attendance in the chat box. Roll number, name and division. Roll number, name and division. Do you all have any doubts up till now? You can ask.
Hello, Bhaiya.
Yes.
I just wanted to ask that will the timings will be same every day or will it fluctuate?
Uh,
Because it will be easier for us to know.
okay, so okay, I'll speak to ma'am and let you know one fixed timing for each session. Okay, most probably 5:30 to 6:30 only we'll have. But today, since ma'am told me I took from 4:30 to 5:30, I had actually told ma'am I'll take from this time. But from next time, we'll have one fixed time, 5:30 to 6:30. I'll confirm it. Okay.
Sure. No, bhaiya.
Any other doubt?
No.
Why do we use ampersand?
See, ampersand variable name means what? At the address of that memory location. See, each variable, how it is stored in memory, each variable is stored in memory in the form of at some location. Suppose you're creating a variable A, how the computer will know? How will it store A? It will store A at some memory location. So that memory location has certain address in your computer memory. Because see, there are so many memory, there is so much memory in your computer. There are different locations in the memory, and each location in the memory has a particular address. For example, there are so many people living in Pune. Each person has a particular address, right? Otherwise, how will you know how to meet that person? Suppose you are staying at Hadapsar. That is your address, Hadapsar. Then some other person might be staying in a camp. So that is his address. You can locate that person at that address. Similarly, a variable you can locate at a particular address in the memory of your computer. So to access that address, how access address means either the content stored at that address you want to know, or you want to store some content at that address. So to store some content at the address, you have to access the address, and to access the address, you have to write ampersand variable name. Means when you write int a is a variable and it is assigned certain location. That certain location has certain address. We want to know what is that address because compiler will automatically assign some address to it. We don't know what is the address. We want to know the address. So for that we use ampersand variable name. Suppose we in scanf I use ampersand variable name. At that address, the value of a will be stored. So I'm accessing the address and I'm storing the value of a at that address. So we write ampersand to access the address. Is your doubt clear?
Yes.
Okay. Any
We
other
can
doubt?
call it as a syntax also, bhaiya.
Yes, that is a particular syntax. Yes. Any other doubt? Okay. Okay, tell me, Pratik.
No, nothing.
Okay. So we'll stop for now. You can leave the meeting. Thank you.
Thank you.
Thank you, bhaiya.
Okay,
Yes.
thank you, bhaiya.
Thank you.
Welcome. Welcome.